Hello guys, welcome back. In this video, let us see in detail about tokenization. Now, let's have a question. Why do we need this tokenization? So, the requirement of this tokenization is, let's say I want to perform any task like summarizing the text, question and answering from the model. I will provide a context and I would like to ask some questions to the model to get the response related to the question. So like that for question and answering. And if you observe for sentiment analysis also and so on, we can able to perform multiple tasks by using any one of the NLP model. By using any one of the natural language processing model, we can able to perform these tasks by using any one of the NLP model. Then, in order to perform any one of the tasks based on my requirement, we need to pass our data or text or our content to our model, right? Yes. So, while passing, what type of data our model is expecting? That type of data we need to pass. Any model will only accept numerical representations only as an input. So, now in order to perform these tasks in real time by using any one of the NLP model, I am having a requirement to convert my input to numerical representation because my input, how it will be actually in the form of sentence, that is nothing but text, right? Yes. Let's take an example. So let's say I want to analyze the sentiment of the text by passing the input. Then here, so what is the first task I need to do? I need to pass my input, right? Yes. So how can I able to pass my input to any one of the natural language processing model? So that we're gonna understood in this video. So what is the text? So let's take a sentence as let's take an example sentence. That is, let's say I am a developer. I am a developer, or I want to become a developer. I want to become a developer. Like this, I want to send this input. I want to send or I want to provide this sentence to any one of the ML model. Then how can I able to provide? Then can I send this sentence directly to my model? No. If I send directly this sentence to my model, then my model do not able to understand that sentence because it only know the numerical representations and it only understood these are numerical representations. Whatever the sentence that I have sent in the form of a text, that our model will not understood. And here one more important point is, if I send any numerical representation instead of the sentence, then my model need to understood that particular numerical representation representing this sentence. How can my model able to understood that numerical representation represents the sentence? So first, initially, that data need to be there, right? Yes. So in order to understood, a numerical representation belongs to particular word or particular sentence or particular character. First, that data, that vocabulary data need to be stored in that model, right? Yes. So let's say if I assign 1 to I and if I assign 2 to this whole sentence, like want this sentence, then I know that so this one represents this I, this two represents this WAN and space before it. How actually like that in vocabulary way, how our model will actually store that data or in what vocabulary our model is using in order to identify our sentence from numerical words. So let's first observe that. so that we can able to further convert the sentence into that numerical representation, and then we can able to pass that data to our model. So let's first observe what vocabulary a model is using in order to understood our sentence based on the numerical representation. So how can we able to get that vocabulary, sir? We already have a library. That library is transformers. So in this library, actually we have tokenizers. That is auto tokenization. Auto tokenizer is there. You can see suggesting. Yeah. This auto tokenizer is already present in this transformers library. By using this auto tokenizer library, by using this auto tokenizer, you can able to actually tokenize a sentence. That is, you can able to convert this sentence into numerical representation. Based on the model that you use, you can use this tokenizer, that is auto tokenizer, to convert this to respective numerical representation, because each and every model have their own tokenizers. So before passing any sentence input to our model, we need to convert our sentence to tokenization by using that particular tokenizer only, because that tokenizer will convert our sentence into numerical representation. So don't worry, we'll understood how the vocabulary is stored for that particular model in the tokenizer as well. By using this auto tokenizer, you can able to load a tokenizer, or you can say you can able to load any model related tokenizer. Let's say I want to load a tokenizer related to BERT model. Then I can able to use this auto tokenizer. You can able to use auto tokenizer dot from pre-trained models. You can able to import a tokenizer. Let's say I want to use BERT base case. I want to use this BERT base cased model to create a tokenizer. So let's say I created a tokenizer. That is, I want to load a tokenizer. Here you can see for this model, by using this auto tokenizer and dot from pre-trained, I loaded this model related tokenizer into this variable. Now, in order to understood this in better way, let's print this tokenizer and let's see what it is printing. What it is printing instead of this. So actually, I'm one bit out. Now I want to run it to check how my tokenizer is loaded. So how my tokenizer is represented. Now you can see, so it's running. Yeah, currently now it is loading the tokenizer. Yeah, you can see. So this is how it will be loaded. So it contains, our tokenizer contains these many things like, so what is the model? Which model tokenizer it is? So that model is there, and how many vocabularies are there? So what is vocabulary? Vocabulary is nothing but each word related or each token related numerical representation. We call word or sentence as a token here. So in case of model, we call it as a token. So for each token numerical representation, we will store in the form of a vocabulary. So like this, how many vocabulary size is there? 28,996. So this actually store these many data of vocabulary. This also specifying me the max length. this represent what is the max length of tokens that we can able to pass to our model. And so it's actually fast, so that's why it is true. And padding, in right side you can able to apply padding. So what is the major requirement of this padding, sir? The major requirement of this padding is whenever you are comparing the similarity between two words or two sentences. During that scenario, the number of tokens for sentence 1 and sentence 2 may not match. One sentence may have large number of tokens compared to other sentence. During that scenario, you use this padding to just match the length of the both sentences before processing that data by using our model. That padding actually happens in right side. And if you see the other things like truncation side is also right side only, as well as special tokens. It contains, this model actually contains special tokens like unknown tokens are represented by using a UNK, and separate tokens are represented by using a SCP. That means if there are two sentences, then they are separated by using this SCP token. And padding. So just now we discussed in order to provide padding to a sentence. So that padding, that extra padding is provided by using this pad tokens. And so while, let's say if I provide this sentence, then actually after tokenizing this sentence, it actually contains the first element is this class token, and the last element is this separate token. So in order to separate the sentences, this becomes the last, and in order to tell this is the starting of the sentence, this token is added. And coming to mask, so this is the mask token. We can actually use it to train a model. Now we have understood how a tokenizer is loaded. Now what I am expecting is I want to see the vocabulary. So what is the vocabulary, or you can say how actually you have seen, right? So what is the vocabulary size of this model? This model vocabulary size is this. So what is vocabulary? Vocabulary is nothing but for particular word, what is the numerical representation? So that is the vocabulary. So in order to identify a word based on numerical representation, it also need a vocabulary, right? Yes. So that we're gonna see now. How can we able to see? You can see we created this, we loaded this tokenizer, right? So by using this tokenizer, you can able to see that tokenizer dot vocab. So this is the thing you can able to use, or you can say this is the method you can able to use to see the vocabulary of that particular model. Now I'm just rerunning it again to see the vocabulary. How? Yeah, you can see multiple vocabularies are there for particular word. Particular numerical representation is assigned already. Now I want to see that in a meaningful manner. I want to see these all in a structured format. For one, what is the word? For two, what is the word? So like that I want to see in a structured format. For that, in order to represent this data in a very structured format, I want to import pandas. So let's import pandas. Yeah, let's import pandas as PD. I think this library was not installed. Yeah. So let's install it. Meanwhile, we install pandas. So this command is used to install the library. So meanwhile, let's continue the commands. So I want to convert this vocabulary, or you can say this dictionary, into pandas data frame. So how can I able to convert this dictionary into data frame? So vocab data frame. In this variable, I want to store that data frame. So in order to create this data frame, I want to use pandas pd dot data frame. What is that? Pd dot data frame. This you can able to use in order to convert your data, or you can say our data, our vocabulary data into data frame. And here we need to provide a dictionary format data, or let's provide the same thing, or let's provide our own, like what is the key and what is the value I want to store for particular variable. Or else you can able to directly provide this vocabulary. So it's actually a dictionary, so you can able to provide. And let's see the data frame, how it looks like. So let's print it so that we can able to get the data frame, vocabulary data frame of this particular model. So like this for every model. So this related to what model? This related to BERT base case model. So like this for every model we have tokenizers. Yeah, I think we got some error in line number 10, that is at here. So let's make it in the form of a dictionary to pass it. So first I want to store tokens, that is nothing but words. So what are the words? Words are nothing but the first keys, right? Yes. So vocab dot keys. So these keys are nothing but words, as well as the second one is I want the token IDs. So words as well as token IDs are stored, right? So vocab dot values. You can able to use values to get all the values of the dictionary, and to get all the keys of the dictionary, you can able to use it. So let's rerun it to see this data in this dictionary formatted data. Yeah, now you can able to observe totally these many rows are there. That is 28,996. And you can see how the data is represented. Yeah, looks good, right? Yes. But the token IDs are not in arranged order, like 0 to ending. I want to sort this data based on ascending order, like 0 from 0 to ending. That is 28,996. Like that, I want order way. I want to see. So in order to see in order way, let's sort the data based on this token ID. So for sorting this, so vocabulary data frame dot sort values. I want to sort values by, so based on what we are sorting, based on this yeah, token ID. Based on this token ID, I want to sort. So that's why I'm copying this and providing that here. And so I want to set a index as well. So here you can see index, I'm getting some random index values. I want to set that index as the same. That is this token ID. I want to set this as index. So I'm providing the token ID. And again, at last, I want to store this sorted data in this vocabulary data frame itself. So I'm storing it. So let's see in a sorted order from 0 to ending. Yeah, you can observe. So first, yeah, this is the sorted order. So from 0 to it was started, and 2000, yeah, something it was there. So up till there, it was there. Now you can observe 0 token is provided for padding. So let's say if we want to provide padding for a sentence, then what it will provide? It will provide a 0. It will provide a 0 for that extra places in a sentence at the place of padding. And one, and you can see, so multiple are there. So let's print. Since a lot of values are there, so that's why the reason we are unable to see the data. So let's download the data in the form of CSV and see the data. So vocab data frame dot to CSV. So this is the method you can able to use in order to load your data in data frame data into your local machine, and you need to provide the CSV file related name like a data.csv, or let's provide a vocab data.csv. And do you want index, then you can provide, or else you can provide, currently I don't want any index, so that's why I'm providing false. So let's rerun it so that my data frame got converted to CSV format, and it will get downloaded into my, yeah, it will get downloaded into my local machine. You can see this is the vocabulary folder. So this is how this is the CSV file that is downloaded. So let's open the CSV file to see the data. Since our index is nothing but the token ID, we need this. So that's why I'm I want to I want this as well. So that's why I'm providing true and rerunning it. Then let's see how the vocabulary of this particular model will be. So like this, for every model, there will be some vocabulary. Permissions denied. So let's provide one. Let's provide another file name, and let's try to do this again. Yeah, you can see. So it's get downloaded. So if you open it, then you can able to see the token ID and the data corresponding to it, right? Yes. So the whole data is there. If you observe, so first few, or you can say first some data will be represented for padding, and you can see for classing, separation, and mask. So like that, for different labels, first approximately, yeah, exactly 105 tokens, or you can say 105 tokens are given for these type of data. Then after, you can see special symbols got started, and up to 120 we have special symbols, and numbers are stored from 121 to 130. And then again special symbols came, and then you can see ABCDs, that is nothing but your letters. Our characters are our characters indication starting from 138. Then yeah, so then special symbols are there. So like that, so for each and every, you can see for different languages, different symbols are there. Those are also stored here. So since it's a language model, multiple languages also got stored, and you can see word related token is also there. So like this, based on token and token ID, this model already have. Based on the token and token ID, this model already have. This a tokenizer. So where is the tokenizer? Yeah, here. So this tokenizer, whatever the tokenizer that we created from that model, that will convert our sentence, into numerical representation, particular corresponding numerical representation. So before converting our sentence into corresponding numerical representation, so this tokenizer will actually split or divide our sentence into tokens, where those every tokens will be present here. So by using that tokens, it will represent the corresponding token IDs. So let's first convert this sentence into tokens to observe how this tokenizer is converting the sentence into tokens. So for that, let's comment this vocabulary representation. I don't want this vocabulary right now. Okay. Now I want to see how this tokenizer will split my sentence. So for that, let's see. So I want tokens, right? Yes. So by using that tokenizer, you can able to use tokenize. You can able to use tokenize. You can able to use this tokenize of this sentence. So this can able to tokenize your sentence, and then let's see the tokens, how it will convert the sentence, or you can say how it will tokenize the sentence. Tokenization is nothing but splitting the sentence. Tokenize is nothing but splitting the sentence. You can see how it is splitted. I is taken as one word, want is taken as one word, to is taken as one word, become is taken as one word, a is taken as one word, developer is taken as one word, and this dot is taken as another word. In this way, actually, it can able to tokenize the sentence. So like this, every tokenizer related to every model will tokenize the sentence. Based on what? Based on the vocabulary, tokenizer vocabulary it has. So actually, this model tokenizer will have the meaning related to this word. That is the numerical representation related to this word. So that's why this splitted like this. Now let's tokenize. That is, these are tokens, right? Yes. So now I want to tokenize these tokens. Nothing but whatever the sentence I have, that I want to tokenize and see how my tokenizer will converting this sentence into numerical representation. So for that, so what we are doing, we are actually converting, or you can say we're getting that tokens IDs, right? Yes. So we are tokenizing nothing but converting the tokens into token IDs. So by using the tokenizer only, you can able to do that. By using the same tokenizer, I am using encode function and providing the same sentence. And let's print these token IDs as well. After these tokens, let's print this token IDs, what we get after encoding that sentence. I'm rerunning this to see these tokens as well as their token IDs. You can see the token as well as token ID, token ID. But if you observe, so totally 1, 2, 3, 4, 5, 6, 7. 7 tokens are there. Coming to token IDs, 1, 2, 3, 4, 5, 6, 7, 8, 9. So why two extra tokens came in this token IDs? Other than the sentence, why two extra tokens will came? The reason behind this is the first token represents that class, and this last token represents the separation, nothing but the ending of the sentence. So let's see that as well. So in order to see these two tokens related words, or these two tokens related representings, I want this vocabulary. So I'm using this vocabulary, and I also require these data frames. So I'm just removing or uncommenting these two, and I want to print, right? So I want to print what is this numerical representation represents in this data frame. So for that, I'm just using the print statement vocab data frame dot item location or item load of this 101, nothing but this token I've provided, and I'm providing the another one as well, that is nothing but this 102. Now I want to rerun this to see so what these two tokens will actually represented in this data frame. So I think some error came. Yeah, PD is not there, so that's the error. So let's rerun it. This importing pandas as PD also we need to uncomment, so that we forgot it. Yeah, you can see. So what does this represents? This represents CLS. What does this 102 token represents? This represents this SEP. So like this, the starting and ending tokens will be represented in a sentence. So that's why the two get extra, and all the middle tokens represent the corresponding tokens, in the tokenized sentence. So now we observed and we analyzed how any modal vocabulary will looks like by using this tokenizer.vocab, and we also analyzed how a tokenizer will tokenizes the sentence by using this how it breaks the sentence, and we also understood the encoding or nothing but token IDs of the sentence. We also identified the token IDs of the sentence, and we also observed why two extra tokens got added to our sentence, and what they are. Nothing but they are specifying the tokens like CLS as well as this SCP to represent the start as well as ending of the sentence. Now, based on these token IDs, whatever generated, I want to decode it. That is, I want to see back. That is, these tokens I want to see back. So, can I able to do that? Yes, we can able to do that. So, just a decode method you can able to use. So, these are the token IDs, right? Now, I'm just printing. I'm just commenting the below, because this vocabularies related code we have already seen. Now let's see how to decode this. So to decode these tokens, so token IDs, let's say you have this encoded sentence, that is these tokens. So by using these token IDs, let's say I want to decode. How we can able to decode that? So in order to decode, you simply write the sentence, that is these token IDs dot de this tokenizer dot decode. So by using the tokenizer, right, you are decoding. Yes, this tokenizer dot decode of. So what you want to decode? This token IDs, this tokens related IDs I want to decode, and then I want to print whatever the response that I am getting to see how what is the decoded tokens. So as per your observation, the first token represents the CLS, and the you can see. So somewhat error I'm no some yeah, these all are warnings. You just ignore them. You can see. So the first one represents a class, and the last one represents this separation, and this is what the sentence I have provided. So by using the token IDs also, you can able to generate the sentence. So from starting from first character to nothing but starting from the first sentence to last sentence I don't want the first as well as last, up to there I want. So like that, that's why I'm providing this slicing. And let's print it to get only the sentence. No, these tokens are not there, right? So let's print the sentence. Let's print this sentence. Yeah, you can see we got this. So again we are running it to see how the sentence will be. So you can see this is the decoded sentence. So like this, actually we represent, we encode this sentence to send the sentence to our model. One more important point, you not only pass these token IDs, apart from these token IDs, you also pass two more parameters. How to generate those? So to generate those, so how to generate those? You can generate those by using tokenizer. By using the tokenizer itself, you can able to generate tokenizer of whatever the sentence that you want to pass, that sentence you will provide. So this will generate you three things. So let's see what three things it will generate, and let's understood what are the three things. First one is these token IDs. You can see input IDs it will generated. That input IDs are nothing but my tokens related IDs. Okay. Then what these token type IDs? These token type IDs represents the type of sentence. What is the input type? Is the input is a prompt, or is the input is question? So like that, in order to provide the variation between different sentences. So this actually uses this token type IDs. Okay, in order to tell the differentiation between inputs, so these token IDs are being given. Okay. So what about these attention masks? So I've already told you these attention masks are nothing but in order to specify is there any padding? Is there any padding? So in order to specify those paddings, these attention masks are there. So in order to observe the padding as well, let's take one more sentence as an example to provide two sentences to this model. So let's say this is the sentence 1, and this sentence 1 is nothing but I am a developer. I am a developer. You can see these two will generate different length tokens, right? Yes. These two sentences will generate me different length tokens, comma, sentence 1 I am passing. Now for the tokenizer, I am passing the sentence as well as sentence 1. That is nothing but these two sentences I am passing. And padding. So here, in order to balance the length, nothing but for the first sentence, it will generate these many tokens. For the second sentence, might these many tokens won't be generated. You can print it as well if you want. So yeah, let's print it to make it clear. For the sentence 1 also, I am taking tokens 1 and printing that. So let's rerun it so that you can able to observe how the output will be. You can see this. Yes. So for this, the number of tokens are these many. For this, the number of tokens are these many, right? Yes. So now here, do I applied any padding? No. So that's why these extra 2 bits are not taken, and here all the padding bits are 1. Now let's say I want to apply the padding. In order to balance the two sentences, I want to apply padding equals to true. So I want to apply the padding, and let's rerun it to see this attention mask. To see this attention mask, I applied the padding. You can see extra 2 zeros got added. That means 2 extra tokens are there in the first sentence. You can see this is the first sentence related attention mask paddings, and these are the attention mask paddings related to second sentence, that is sentence 1. Here you can see 2 zeros are added, nothing but 2 extra padding bits got added here, whereas in previously 2 extra paddings are not added, so that's why there is no padding here, right? Yes. So nothing but 2 zeros are there. These 2 represents the padding. Previously, before padding, there is no 2 extra zeros. After padding, now 2 extra zeros came. So that's the, so in order to represent that padding, this attention mask is used. So this whole data, nothing but this all data will pass as tokenized data to our embeddings or to our model. So if we recap it, then from where we imported the tokenizer, we imported the tokenizer from transformers library by using this auto transformers, and we provided the model for which model we want to create this tokenizer, and we have taken a sample sentence and we tokenized that sentence as well to see how the token representation of this sentence as well. And then we previously seen what is the vocabulary, that is nothing but how this model is remembering, this model is identifying what word represent what numerical representation. So that vocabulary we have saved in this vocab data 1 file, and we have seen that vocabulary how it will be, and then we just simply tokenized our sentence, that is nothing but we taken a sample sentence and we tokenized that sentence by using this tokenizer or tokenize function. Then after we encoded that sentence, nothing but we generated the token IDs from the tokens, and we also understood what are the other parameters will pass to the model before we sending the data. You can see we provided the tokenized inputs, nothing but input IDs, and we are passing these token type IDs, nothing but in order to represent what is that token type. So in order to represent different inputs, nothing but if you take an example, then question and answering, or you can say context, in order to differentiate between different types of inputs, this token type IDs are created. And these attention masks actually to represent padding. So is there any extra padding happened or not? So that to represent that, you can see extra zeros are there. So that representing by using this attention mask. So that's it all about this tokenization in-depth analysis. So I hope you understood this video and you understood some more important and detailed concepts, and you observed that detailed observation of this tokenization, how any model will understood the numerical representation that we create by using this tokenizers, and how actually the vocabulary of this tokenizer will be for any model, and what we will pass as an input to our tokenizer. You can see this data will pass as an input to our tokenizer, and you also observed what are the major components in it. So that's it all about this video. I hope you understood this video and you got some clear conceptual knowledge. If you feel this video is useful, then please like it so that it will be very supporting to me, and type your comment so that I can able to understood your feeling. And don't forget to subscribe to my channel to watch such informative videos. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye guys.